circle's length is located in the y direction and none of it in the x direction. Similarly for over here, the angle pi, formed by the x-axis and the negative x-axis, we have the coordinates -1, 0, corresponding to the unit circle length being all in the negative x direction. And the last one, 3 pi over 2, has the coordinates 0 for x and -1 for y. So we want to take that information, especially when we interpret this particular information with a function of theta called sine of theta, right? And so if we were going to do an XY chart, excuse me, not XY, let's do theta and f of theta, similar to an XY chart, but we'll call it different things. Theta and f of theta, which is basically our XY chart. So we're going to continue the knowledge of the unit circle, but we're going to try to graph the basic functionality of it. We say, okay, if theta is 0, right, then f of theta is what? Well, we're talking about sine. So one of the big takeaways from the quiz is, do you know that the x component is cosine of theta? And do you know that the y component is sine of theta? Okay? So if I'm looking at this as the initial angle, the positive x, and I'm saying the terminal side is 0, then we're going to look at this value here to get the sine of theta. So the output is going to be 0. All right? So if we're going to graph that, right, then we're going to look at two values. This y-axis we'll call f of theta, and this x-axis we'll call theta, right? And so when we're at theta is 0, we're here, because f of theta is also 0, right? But there are some other points that we know because of this unit circle, and another one is pi over 2, right? So when theta is pi over 2, right? Let's say that call this pi over 2. What's going on? Well, we just look at the unit circle and we look at the sine value and we say, oh, it's 1. Okay, so that means that I'm going to go, let's say, here. Okay? When theta is pi over 2, the output is 1. When theta is pi, what do we have? We have back to 0 again. So that would be, this is pi, and we'll go back to there. And then we have 3 pi over 2 for theta, and the output is down here, where it says 0, -1. So the output is going to be the sine, is always a sine for this function we're looking at, sine of theta. So the output is going to be -1. So that means I'm going to go down here to -1 and plot this here. So up here is +1. But once we get to 2 pi, what happens? Well, we're back to the beginning. The terminal side will be the initial side, and the sine of theta should be 0. Okay? And that is a period, meaning the length of the graph before it starts to repeat itself, if it does repeat itself. And we know that it repeats itself because if we added another pi over 2 to 2 pi, we would say pi over 2 plus 2 pi is what? Well, 2 pi is not in 2s, so we say pi over 2 plus, let's say, 4 pi over 2. It's just 5 pi over 2. So when theta is 5 pi over 2, we're back up here at 1. So now we know that it does repeat, because from here to here is repeating, and from here to here is also repeating. So we know that it's going to go like this. And so now we can make an interpretation of this graph, because we have our points plotted, and we I'm sorry, let me just label this. This is 3 pi over 2. This is 2 pi, and this is 5 pi over 2. Now we can attempt to make a smooth line based on these points, right? So we get something like this. And that's how we start the sine, all right? We have period to think about, and we have amplitude. Well, amplitude for this one, the highest it goes up is 1, positive 1, and negative 1. So the amplitude of this function is the distance from the x-axis, or up to 1. So this is amplitude. I'll just put A there. And so that's 1. And the period is going to be starting at theta is 0 and going to 2 pi, because right here is where it starts to repeat itself. So from the origin to 2 pi is our period. All right, period. I'll just put a P there for now. So we're going to say 2 pi. Thank you for watching.